do. And so that's what we had. We had a small handful of engineers, and we were building software that was very tightly coupled. We had a single database, and then an MVC framework that was interacting with that database. And over time, you start with a few thousand lines of code, then 10,000, then 50,000 lines of code, and you just keep building from this one code base. And one day, 3-4 years later, you find yourself with this massive program that is now very, very hard to change. And when you make a change to it, all of a sudden you get all kinds of bugs, failures, and things start going crazy. And now you're scared to actually change it, and you don't actually know what to do. NewsCred found itself in that kind of place, a few years ago, and that's when we said, hey, let's go ahead and solve this problem, and why don't we do it using microservices architecture? And our approach to that, roughly, was to take a look at our system and find how could we split this thing up into smaller pieces and make these code bases smaller. And that is the journey and the path that we're on right now to transition from our old architecture, which is a monolith, into this microservices architecture. And we believe that it is an excellent way to design systems for a growing company that needs to have 20, 30, 40, 50, 100 engineers working together in collaboration to deliver a software solution. So anyway, I want to stop talking because the real stars of the show are waiting here, and I'm going to hand it over to them.
Hi everyone, I'm DJ, and I've been at NewsCred for about 5 years now. So what that means is when I started here, we were actually kind of in the middle of that monolith that Asif just mentioned. I helped build it. A lot of the engineers here don't like me because I helped create this giant code base that's really hard to develop in these days. But now we're trying to fix it. So yeah. So I'll give you a quick overview of what we're going to talk to you about today, and then we'll actually start talking to you about it. So microservices, are they new? Why haven't I heard of them before? Microservice model, diving deeper into some of what Asif just said about actually, what is the distinction between the two. Traits of a microservice, doing a bit of a deep dive into, okay, I have microservices, what does that actually mean for me? How do you actually go about that process of coming from going from a monolith to microservices? And then the last thing is deployment strategy. Wow, sorry, I'm having trouble with this microphone. Last thing is deployment strategies. How do you actually deploy microservices? Well, a lot of people have experience there. So cool, microservices, are they a new thing? And the answer is actually no. Microservices are pretty much just a rebrand of service-oriented architecture. There's some distinction between the two. They're a lot smaller by definition, but you've probably heard of service-oriented architecture before. It's been around for ages. Microservices are kind of just a clarification on top of that, a subset of that. The main distinction being they're much, much smaller. So if you've heard of service-oriented architecture before, you've heard of microservices. Microservice versus monolith. What's actually the difference between the two of them? So the important thing to actually look at here is not the individual boxes. Hold on, Brad, I use a laser pointer on this thing. Red button, cool. Appreciate it. So it's not the actual words here, but the idea is in a monolith you have a couple small components, like really just one. And then in a microservice, it's going crazy. There's all sorts of different network connections, all sorts of things connected, or your systems diagram is a lot more complicated. So what does that imply? This super complex system, what does that actually imply for your development? What does that mean? Why do I want a microservices instead of a monolith? One reason might be maintainability. What's the difference between a microservice and a monolith in terms of maintainability? Well, one thing is, in a microservice, you might have 10 systems, and each of them is 1/10 the size of that monolithic system. And that sounds good. Yay, less code. With less code, it's a lot easier for a developer to onboard into a system. They might be able to come in, understand that system in maybe a day or two, and rewrite the entire thing in a couple weeks. And that's definitely pretty desirable because all of a sudden your onboarding time into a new system is just way, way smaller. But there is a disadvantage, and that's you have smaller systems, but you have more of them. And what this means is that same developer that rewrote an entire system in a week or two might take a month to understand how all these different systems fit together. In a monolith, on the other hand, what's going to happen is they might take a month to onboard into the entire code base, but they don't really have that same system level complexity. So you kind of need to, it's a trade-off, which one is the right thing. For NewsCred and for a lot of companies, we think the answer is when that monolith is small enough, you could just when the monolith stays small enough and you're a small enough company that everyone can fit in their head, monolith's okay, but eventually that's going to be too complicated. You need to lower the average onboarding time for everybody. Deployability. What's the difference in deploying a monolith and deploying a microservices architecture? With microservices, there's a lot more to deploy. All of a sudden, I have something like 10, 20 different services that all need to be deployed separately. That sounds like a lot of complexity. Why would I ever take that on? And one answer is, well, there's a lot less to know about each deploy. At NewsCred, we have a system called the platform. And the platform was actually sometimes difficult to deploy to because it did, 5 different things, and you never knew if one of those things was kind of critical at that point in time. Is it safe to shut down this platform right now for some kind of maintenance? Is it safe to deploy right now? And you never really knew the answer to that unless you were intimately familiar with everything it did. And asking that intimate knowledge of a system that's super big isn't really reasonable. With a microservice, it's very easy for someone to know exactly what it's doing, exactly what it's responsible for, and thus your deploys are a lot easier to understand. You know when deploying is okay. In microservices, one thing that these microservices actually allow you to do is individual small teams can make their own decisions. If you go into a monolithic app, all of a sudden you have one database and you have one programming language, and everyone needs to be on board with that. Now all of a sudden you're looking for specific types of people that know how to do specific things. Well, in a microservices architecture, you don't have those same constraints. And what that means is individuals can actually, or small teams come in and say, hey, we think the right tool for this job is language X, and we think the right database for this job is, database Y. And they could actually do that because you're creating something new, something small, that solves the exact problem at hand. And a purpose-built solution is generally going to be better than trying to fit it into your already existing system. Microservices is eventually consistent. Kind of mentioned that with those more failure modes, network calls. You don't have transactions. Life is hard. And with those network calls, you need to design for failure. There's so many different things happening that you need to know they're going to fail. Microservices have more failure modes than a normal monolithic app does because of that. That's hard, and you got to keep that in mind.
So there has been some contradiction between how should we start writing a microservice. Should we start from a monolith, or we should start from the microservice from the scratch? So we have 2 versions of that as well. So here it says that monolith first. The reason monolith can work well when you start from monolith is like you have an application that actually works, which means you have a business problem and a solution for that. So now you know how it works, okay? So you know what are the module boundaries. You know what are the objects that have to be defined there. Okay, so now you can actually make a slice out of that and make a separate service, which is another microservice. Okay, so that is the logical derivation for coming up with monolith first. It is actually a very logical derivation for the people who already has a monolith and want to break it up to microservices. That is the case for us right now. So there is another alternate approach as well. Some people say that we can start with the microservice first as well. Well, the hope is that all the monoliths that we have has a very good modular system with which each module talk to each other. But that is not the reality actually. sometimes what happens is like particular applications are so spaghetti. If you want to slice a part out of that, then it will be much harder to do that. It's better to start with the microservice first in that kind of approach. So we'll actually share one of our scenario how we actually took up a microservice and made a slice out of that. I took up a monolith and make a slice out of that to come up with a microservice. So Zahid is going to talk more about that here.
How do you, when you go from monolith to some microservices, you already have the monolith system built on your everything, right? Your company now has it live, your clients are using it, correct? Now you're changing the entire stack, splitting into two. There are two deployment services. Everything is two. You have two double teams. Two are coordinating each other. How do you do those? So there are a lot of challenges. The first thing is, and the first and foremost thing is, you cannot make your application down. You cannot turn off your application for 3 days. Like, think about it. Google turning off their search engine for 3 days. Everybody is going to go out of the internet. It's not going to be even possible. And YouTube, oh my God. So think about this. All of these services that clients are consuming, they're depending on them. So the application that we build, clients depending on every single day, every single hour on them, and they're actually uploading them, right? So now, we need to be very careful on how we split that up. So let me give you some context of what our application was. This is a CMC, which is a content marketing platform, which Asif just told you that we are a content marketing software company. So this is one of the products that we have. But there is a backend system, which DJ said that the platform, it's a big monolith. That's another API that we serve. So this is how they communicate. CMC gathers their content from the platform. So that's the ideal situation. Both of them are huge monoliths. So we're going to help to understand, like to figure out some boundary of the platform to split that up and get some more like microservices out. All right. So first thing is we need to figure out what the interfaces are. By interface, we're considering the boundaries. So we figured out two things. One is a licensed content, the content that we ingest from providers, and the one that actually the user can create by themselves. Is that clear? Two different contents? Like one that you write and the other is from the book. All right? Cool. So now once we understand that there's two different things, one is provided by the book, some author did that, but the other one is in my actual copy, which my teacher is going to look into. So these are two different things. There are different scenarios in the business, there are different things in the approach, everything, right? So we can naturally divide them into two so that we can have different business logic and more constraints around them. All right. So now then, the assets is born. So we consider everything that we create is our asset, right? Because the book that actually the author writes, everyone has that. But the one that you create, your copy, it's your own notebook, unless you share it with your friends. So, so that's how we get the assets. So once we introduce the new service, do we do everything, like create everything from them? No. If I start in a single deployment, created the entire service, it's going to fail like that. So what did we do? We introduced the assets, but the customer content connects the assets, but the asset still talks to the platform. So it is nothing but just like a gateway or a proxy or adapter. It takes in an information, just escalates that to the platform, and they're taking all these responses. Make sense? Fantastic. Moving forward. So now, we start doing double writes to the new storage. What do? Before, when we were creating a customer content, we were proxying that and towards the platform. But right now, we're going to still do that because we know that works. We're not going to remove it yet. But we still want to write those information to the assets itself. And we're going to introduce a new storage of it. Perfectly make sense? If no one understands at any point, please stop me. Great. So now that we write to the new storage, it's a double write. We're still writing to the storage, and also we're writing to the platform, the one that we already trust. Moving forward, now we migrate the data from platform to the existing one, because we have been double writing from that moment when we deploy. But there's a historical bunch of tasks, like articles and everything. We want to make sure that those are there in our storage, right? Because we're migrating from that. Fantastic. Now we do the migration by this. From platform, we write a script or do something and migrate this data to the assets. Now the assets have all the previous ones in their own storage and also the new ones. because we're doing a double write. Make sense? Fantastic. Now we start doing one thing. We don't get platform back to the assets. You see, the arrow, this arrow is changed. We're not getting platform back to the assets anymore. What are we doing? We're reading from the new service storage. But we still have that line. Why? Because let's say something fails. Once we start reading, we have some problem. Do we have a way to get back? We still have, because we have still the array. We still do the double write. Now once that is done, everything is ready. We're reading from it, we're creating stuff, everything looks fine. The new service is born. Now that we have multiple services, how do we deploy them to production?
Hey everyone, I'm Rana. So I think like on my previous speakers, they sold microservices pretty much to everybody else. Oh, sorry, yeah. Yeah, I think my previous speakers, they sold microservices to all of you. So how many of you are like positive to microservices? Can you please raise your hand? Yeah, that's really disappointing. Okay, so like when you deploy microservice, when you go for microservice paradigm, so like we were discussing before, and I think like the first thing when you architect your microservice, the first thing that probably will bump to you that like previously you have like one system, one monolith, and now you broke it up and you have like n number of systems. So you have like, if you had previously like one problem, now you have like n number of problems. So one of them is like deployment. Previously you used to deploy to one of your systems. Now you have like n number of systems. How you are gonna like efficiently like deploy to all these systems? So there's some common traits of like deployment to microservices is like, so frequency of deployment in microservices is really high because you break up into microservices so that you can iterate over your code faster. Right. And like obviously there are like lots of microservices and one of the very important thing is like, so when you have like 10 different services, so it's very important to ensure that when you deploy to one of them, it doesn't break all of the like the entire architecture. So like that's the requirement of like high availability. So we included this slide at the like very last moment because so how many of you are like familiar with like configuration management? It's just Brian. Okay, so yeah, it's Brian and DJ, and like none of my like coworkers. That's really sad. I used to be an evangelist of like, configuration management in the company. So so what configuration management is like basically you define your system state in code. Let's say like how many of you are like familiar with WordPress? Okay, so how many of you actually like install WordPress somewhere? It could be anywhere. It could be like development environment or production. Okay, so what do you do to install WordPress? Can anyone like explain? Like the basic steps. Do you install like everything from source or like with apt-get? But like there are like manual steps involved, right? It's like, so when you have like microservices, you have like n number of different systems. So I'm sure like none of you want to manage these systems manually. That means you like, let's say today you architected a microservices that has like 5 components, and I'm sure like nobody wants to like configure these 5 systems manually. And in case if you have to do it again, you're not gonna like do it again manually, like run all those commands and do all those things. You guys are developers, right? So yeah, that's what configuration management does. So like for microservices, it's very important that you build a very solid configuration management that you can use to like spin up all your like components in microservices. So another example is like that DJ was like talking to me like a few hours ago. It's like, so for him, like it might take like let's say like half a day to reconfigure our platform that has like let's say 8 components. But for a new developer, like it's not going to be that much easy. Like if he has to go through like all those like configurations manually, like spin those things up. So if I'm trying to sell microservices to a new developer, like he won't be able to like configure all these things manually, and like he won't be even like interested to it, like because it's like previously with a monolith, it was like one system, and now with microservices it's n number of systems. So that's not feasible. So that's where like configuration management came in. So when you are like architecting for microservices, so it should be in your planning board that like you build a very solid configuration management that you can reuse over and over again. So okay, so talking about the, let's talk back about the deployments. So like when you have now like n number of systems and you have to like deploy codes to them, so what could be the strategy? So like talking about like coming from NewsCred experience, so we went for like CI and CD systems. So that is like continuous integration and continuous deployment. How many of you are like familiar with these terms? Okay, Brian, would you like to like explain it a bit?
Continuous deployment system is when you make changes to your code base, that those changes very quickly, as soon as possible, make it out to your production environment. Typically, it's run through some form of build automation and test automation. Once the build and test complete, then the code is automatically shipped to the production environment and is live for all of the users. Continuous integration is a subset of continuous deployment where you just have the build and the test process that is continuously running against your code base as any changes are happening to it, but not yet actually deploying it to your production environment.
Excellent. Thanks, Brian. So yeah, like the formal definition, like it says like you will be able to like you should be able to like reliably ship your code into production. And that says like continuous integration will enable you to run tests against your code before you ship it to your production, so that you can just make sure like it will not break your production environment. So that's it. So for microservices, so the continuous deployment or continuous integration should be architected in a way so that it's scalable. So what we do like for continuous deployment, we call the process is a like delivery pipeline. This pipeline is nothing but like a single commit into a master branch that code like shipped into the production. That's the entire pipeline. For NewsCred, it looks like something like this. So this is basically like, are you guys familiar with GitHub? Okay, so like this is just an example. It could be like any source code management system. So whenever there will be a commit in for NewsCred, whenever there is a commit in like GitHub's master branch, so that triggers the Jenkins build. Jenkins is basically like a software that enables you to like create the CI or CD processes. There are like other alternatives. So the commit will like trigger a build process in Jenkins, and that build will basically run some tests, unit tests and some other tests. So this test will make sure like whatever you are changing in your code, like they are not breaking your existing functionalities. And if that test fails, like Jenkins will send out email to developers. And if that test passes, we will create some build artifacts. This build artifacts basically nothing but like the code and some like necessary configurations. And that for us, we usually like store these build artifacts into some Debian repository because like our build artifacts is like mostly like Debian packages. And when that like artifact creation is done, it will basically trigger another Jenkins job that will take over and that will ship that code into production. So for us, like we are heavily into like Amazon Web Services. Those are like so basically deploy those codes into like different like virtual machines. So this is one build pipeline. So let's say when you have like 5 different components in your microservices, how are you gonna scale this? Because like there are like many different components involved. So it's really simple for microservices. You just like parallel. You just create like parallel like build pipelines. So the scaling is like really simple here. So whenever you like introduce a new component into your microservices, you just create another like pipeline. So yeah, I hope like it will like at least inspire you to like go for microservices. We do like 20 to 30 or 50 to 60 deployments per day. That means like that much release per day. And we have like many different roles, that means many different apps like across all these like servers. And yeah, like Zahid is really patient to answer the question. But yeah, like we have like, if I can go back to the slide. So the integration test ensures that like we are not breaking anything first, like that's the first thing. So whenever the like developers are iterating over something, they write test cases to ensure like whatever they're writing, it will not break the existing features or stuff.
So that means you don't have any UI, any user interface. What you have, all the output is kind of service.
No. Thank you very much for the question, by the way. It's a fantastic question. One of the things that we haven't pointed out, but this question's answer will point out the root thing of that, is going towards from a monolith to all these like different kind of build cycles towards a microservice and continuous integration and delivery will require an entire organization concept change. How do you do that? Like, we have an agile team, and every single story that we create and which can actually ship towards like a production environment, we have someone, a product representative with us who actually checks it out, who is kind of like our source of truth for the customer. He talks to the customer, we talk to the customer even before we start on working on something. We have mock-ups, we have things that we show to the customers. So we're talking about UI. Yes, we validate those UI. Not only that we validate a UI, we also validate whether that's something that we're providing to the customer is valuable towards them. Every single thing is validated before that goes in. And that's even, that thing that you talked about UI and everything, that's even worked out before we start coding. Once we start coding, we know that these are the things that we want. And once we have that, we just go through our product owner to understand whether that works or not. And how do we do it? Sometimes take a staging environment, which is replicated like a production, and it has fake data and everything. We have some staging environment that can run, and also our local environment can help that as well. And about the unit test, every single time you see the list, there's a build task list. Continuous integration includes those processes. Like, if you have a code, you need to make sure that you're writing test cases, because if you write a code, it's going to go to the production, it can fail everything, and you can screw up everything, right? So you need to make sure whatever you're writing, that is of good quality and with good test cases written around it. And if you need good integration tests, you should write them before we move out to like going towards a push to the master and get to the production. So you have all the code review process is another process that goes through, like, you may make mistakes, but my peer is gonna get an eagle eye on your code, whatever you wrote, and he's gonna try to scrutinize you to the point that it's perfect. And two people, if they're very confident of the code, that's probably great. And that's how it is. Does that answer your question?
Yeah, maybe partly the last one is sometimes it happens like sometimes business is not ready to take the new changes, but you have already written the code and code in production. But business is not ready yet, I mean the customer is not ready yet. Maybe they are thinking that those changes coming the next week, but change is already in production.
Fantastic. So there is a concept which, sorry.
We have something like that.
Yeah, so there is a concept which we use, but we don't like to use that, because we want to get a new thing in production, then we want our customers to be using that. But there are situations where we have something which we're unsure of the complete experience, and we want to beta test that with some other clients before like putting it to everyone. We call those feature flags. So we have an integrated in our system that's called a feature flag, which we can turn on for individual customers or for our demoing purposes, for our testing purposes in production environment. And once everything is ready and we're confident that it will go to all the customers and it's going to be delighting the customers, we just remove those feature flags and one feature is open for everyone. Make sense? Please.
Okay, does that answer your question?
I have a question about the deployment. Before that, since there was a question follow-up last time, I'm saying actually this question doesn't relate. I mean, like, it relates to Microservices deployment, but these challenges are easily made if all the processes are followed from the beginning. Like, for example, if there is a state, if there is a perfect continuous deployment system, then any check-in that you do the deployment and things like that. Now what happens is, what I'm asking is what not you do, but what is the best practice to follow. If, for example, each individual deployments, they need to, for example, refer to any resource that does not reside in the Docker's VM. That is one scenario. So what do one person do in such cases? Will she or he use content data network or similar patterns, for example, any resource that that can be used that should not reside inside the VM or inside, or if any resource that is required in the Docker file or from your program that needs to reside in a separate CDN, maybe within your network. What is the best practice? That was my question.
So we're not using Docker in production, but the similar stuff that we do with our configuration management, when there is a code and there is a configuration which is production configuration. You're saying that that should not reside in the code, but should go into the artifact, right?
Yes.
So when we do the Jenkins process, when we build the artifact, what we do, we have that those configurations, we deploy those configurations to the production agents. So our application actually load configuration from a specific path, and those configurations are deployed in that, environment.
So whenever a new particular resource is added, then the configuration file also needs to be updated. Is
Yes.
that the process?
Can I add something there? Yeah, so like the way we orchestrated our CI/CD process, like is with the help of Ansible. I think there was another question like how we are like orchestrating this with Go or something else. So we orchestrated this with Ansible. So whenever we are deploying, we are not only deploying code, but we are also deploying configuration. So every time we deploy, the system makes sure that the system, the end state is like in a like consistent state. So if it's a production machine, so the configuration management will make sure like it has all the production related configurations. So if you need to add something, let's say like you included a new Redis database. So what you have to do, like we are not fully into service discovery. So we are like using a mix match of like Python and Ansible inventory. So we are actively looking into full-fledged service discovery. So what our inventory does, it looks through all the like production fleet, and based on certain tags, it figures out what is the production rate for this certain row, and it appends that into the configuration. Does that answer your question?
Partially, I think I got my answer from
Okay.
I got answer from Mr.
Jitu. Yeah. Okay. Thank you.
Yeah.
Yeah. Any more questions? Yeah.
So I will ask some basic questions. So the main decision for switching to microservice was that better code maintainability and getting a developer on board with the code base very fast, right? These are the two main advantages.
Yeah, that's definitely two of the biggest advantages. Is here, I'm going to pull up the slide for you again when I get a chance. So those are definitely two big advantages. Is generally getting someone into a code base very quickly, but it's more than just onboarding. It's also general maintainability of something. When we have a new feature request, when it's time to build something new, I could do that a lot faster if I only have 4 files to look through than if I have 50 files to look through. So the idea is less code is kind of an asset in that way. The less code I have, the easier it is for me to change that code.
Correct. So consider this situation.
It's fine.
Yeah.
So hypothetically, we have a code base which is very modular. So there is no spaghetti code. Okay, and yeah, the code base is very well maintained, but it's monolithical. So in that scenario, we are not getting an advantage because all the microservices are actually some well-defined modules in our monolithic system. Exactly. So in that case, the network overhead will be a great issue, right? Because right now I am working on such a project. We have 10 to 12 microservices, and we have to write a very, what should I say, fail-safe code to ensure that no network outage will affect the existing systems. But I think if we just go with the monolithic design, then those issues will not arise. So why should we go to microservice?
Sure, absolutely. I'll repeat the question just so everyone else could hear, and then I'll answer it for you, or try to. So the question was essentially, why use microservices as opposed to, why use microservices instead of kind of beautifully modular monolithic code? Microservices are inherently hard. The network makes things hard. So instead of doing that, how about you do something like write really well modularized code? Instead of 12 microservices, why don't you have 12 modules within one monolith? And the answer, in my opinion, is in practice, those beautiful modules don't exist.
Yeah.
I could try to write, one individual might come in and say, these 12 modules make perfect sense, and I will respect the module boundaries. And that individual might be able to do it for him or herself, but the minute you have a second developer come on board, they are all of a sudden going to disagree about a module boundary and maybe disrespect it, and now all of a sudden you don't have the modules you set out to have initially. While the network is a boundary that cannot be disrespected. You cannot look into the internals of someone else's code, or look into the internals and use it in a different way if all you have to rely on is whatever network interface that they provide for you. So I would call it actually kind of defensive. Microservices are almost defense against humans being humans. We will, if given the opportunity to not build perfect code, we won't. And sure.
Really, depending on where you are in your life cycle, what it is that you're doing, a monolith might actually be right for you. How many people are you working with presently? How big is the team?
4.
With 4 people, it's a very different problem than if it was with 40 people who are contributing code. So really, what are the problems that you're facing? How early are you in the project? Is it the right time for you? Are you receiving a benefit to it? One of the progressions that we sort of said, or that we said earlier tonight, was with NewsCred, we started off with a small number of engineers. It was easy for them to collaborate, for them to understand what it was that they were doing, and to communicate the changes they were making. As we grew from having 4 engineers to having 50 engineers, it became quite a nightmare. We had multiple teams all making code changes into the same code base with independence, which means with no communication and coordination. You can imagine well-intentions happening across 5 or 6 different teams, all trying to do different things with different objectives in a single code base. Those boundaries, those beautiful boundaries you were talking about, and just high-quality programming falls apart pretty quick as you scale the number of people who are in there. So with microservices, one of the great benefits, as you scale up your organization, you have more services with more independence, and you can really scale out in a more effective and efficient way. The scalability isn't just on there. If again, as was mentioned earlier, if you're suffering from scalability issues, you can really fix wherever your core problem is. An example of this that we see pretty clearly and easily is around databases, something like this. If you have a single database and you have many tables in those in the database, your scalability of that RDBMS is pretty bad. It's pretty hard to scale that, right? You have a multi-terabyte database, and you have one table that you need high performance. Well, you have to now figure out how to get high performance on this giant RDBMS that you're going to have multiple slaves of. If you have a microservices architecture, your data stores coupled with your small services, now each of your data types you can individually scale. You can build out what it is that you need for them. You don't end up with giant problems that you have to scale simultaneously.
Thanks. Thanks, Peter.
Absolutely. Absolutely.
If you already embraced it, then this microservice is not that new. It's a subset of SOA. And yeah, so actually I don't know much about the microservice, but I heard a lot of things from there. My question is, we had SOA since last decade. But
Sure. So
How it is different from event sourcing?
how is it different from event sourcing? Could you ask? Yeah, absolutely. Yeah. So the first question, I believe, was why the technology, kind of a comparison of microservices versus service-oriented architecture, and you mentioned some of the standard technologies in service-oriented architecture, like ESB, service buses. These are things that don't really exist in the microservice world. And I think one of the biggest advantages that microservices has over service-oriented architecture using ESBs is the fact that they're really kind of rarer systems that only exist in enterprise applications. Same applications that you've built on your own, you get to reuse some of those patterns in a way that ends up building a highly scalable, very, very good system without adding additional complexity than the ESB tends to. So that's why I personally prefer a microservice instead of service-oriented architectures. There's no unnecessary complexity. It's the exact tools I was already familiar with, and I could expect most developers to already be familiar with. They get to continue using and continue building on. I think the next question was about event sourcing versus microservices. So microservices are a way for two systems to communicate with each other across kind of a way for two different systems to communicate with each other that achieve two different things. As we mentioned, or as Zahid mentioned during our presentation, we have two different services, one called the platform, or for licensed content, and one called assets, which is for customer content. You have the page in a book, and then you have your copy of it, and those are two different services. Event sourcing is an architectural pattern that might be used by an individual one of those services, and actually here at NewsCred we do exactly that. So event sourcing is kind of something you might build a single component with, a single one of those systems, but microservices is a philosophy of how big each of those individual systems should be and how they communicate to each other.
Can you just define event sourcing real quick?
Sure. So the definition, for those interested, the definition of event sourcing is the idea that you should be able to recompute kind of the state of your data and the state of your system at any given time based on a change log in your system. So to tie it back to that page of a book scenario, maybe you have a page in a book and then maybe someone crosses out a word and replaces it. Then someone deletes a line and then somebody changes the page number for some reason. Those are all changes that can happen to a page. And there are kind of two different ways to handle that. You can either just update your row in the database, or you keep a change log of all of the updates that happen to your row in the database and apply that change log. Event sourcing is that second model. It's that idea of applying all of your individual changes, or it's keeping track of all your individual changes, so that if I were ever wondering, what was the state of my data 2 days ago? I could just replay all of the changes up until 2 days ago. Or if I wanted to recompute my database from scratch, I could do that by just taking every single change that happened and replaying them on top of each other in succession. And that would recompute the state. So a microservice, which is, code and its own database, and a database, could actually use that philosophy to manage its data if it wanted to. And sometimes it's the right thing, sometimes it's not. For us, we have a handful of systems that do exactly that. Did those two answers make sense? Can I clarify anything?
Placed, not delivered. So that can be stored in a database, right? Yeah. That can have its own state, but at least you know that part you have got up to, right? And then it delivers to the next service, like the payment is initiated. Right. So it has its own state about the payment state. Okay, so the payment is initiated, and maybe that has failed, and that doesn't trigger a shipment. Okay, up till that we're clear. Okay, so but you will need a distributed transaction for that. You have the order and the state is initiated but failed. There is no need for having distributed transaction for that.
So what I was saying, is this microservice architecture, or what we know is that this is traditional SWA.
No, I mean that's microservice and that's SOA as well. Microservice is a subset of the SOA.
Oh.
It's like the microservice what they have its own trait and they tends to take a small approach, I mean simplified approach to implement the SOA. You don't have to like implement the enterprise bus services or something like that. The simplistic approach of implementing SOA, which has its own kind of trait, which we talked about. So it's not something. I mean, it's not traditionally new thing that we had we shown in our slides.
So just to add to one of the points is, you would see like SOA is the big one, microservices underneath is a subset. So it's more defined SOA. Because in SOA it's not necessary that you have your services independent. If you're talking about EC2, you're using AWS. Did you know about ELB?
Yeah. Yes.
Are you using ELB?
I did.
So what kind of load balancing are you looking for?
One is for the notification is kind of worker, so maybe one.
Is it the notification or the?
I'm using right now the Heroku for notification.
All right.
But I'm thinking to make it at AWS.
The reason I'm asking a question to you, but I mean, which part of the application you're looking for the balance? In which layer? Is it the notification or the?
I just wanted to know how you guys.
So the key in scaling anything is recognizing what your bottlenecks are. In microservices, kind of what Brian just said, you have a lot more systems, a lot more things to monitor. It is often more difficult to know where your bottleneck is because even following the lifecycle of a single request is complicated. But that said, you need to find where your bottleneck is. I could make an argument for why that's easier in microservices because in individual systems, CPU might spike as opposed to just like, oh, my one server CPU spike. So identifying the bottleneck and then sharding, preferably, and then just trying to scale horizontally is kind of your end goal here. I had mentioned the ELB. That's a way that you can easily scale your web server unless you're some of your application logic horizontally. But maybe your actual scaling issues are at the database layer, in which case you can find a way to scale your database. You can scale your database vertically, get a bigger server, or maybe you can start splitting things into microservices because you have one request that happens once an hour, but keeps the database busy for an hour, and then everything else that's happening is kind of more consistent traffic and it's being slowed down by that one request. And as it so happens, they represent logical business units as well. If that's the case, microservices can easily solve your problem. Other alternatives, if that's not the case, are things like giving something a dedicated slave, and then isolating your reads from expensive things. But always identify your bottlenecks, and then from there.
If anyone else wants to talk, we'll be up here, but turning the mic off. Just come on up, and we can continue the conversation. Thank you guys.
Thank
Thanks
you.
a lot.